Hello everyone, welcome back. So in this video we'll see the solution of algebraic and transcendental equations. Okay, so if you are first time to my channel, please consider subscribing. Okay. So first of all, we'll see what is the algebraic equation, what is transcendental equation, and we'll know the basics of iterative methods. Okay, so with this knowledge, then we can go for the methods of solving these algebraic or transcendental equations. Okay, so in this video, we'll confine ourselves to knowing about algebraic and transcendental equations, what are those, and next is about iterative methods. Okay, so the formulas for the different types of methods to solve these algebraic or transcendental equation I'll discuss in the next video. Okay, so what is algebraic equation or algebraic function or equation, anything? Okay, so algebraic equation, so a function or an equation involving sum or difference or product of two or more polynomials. Okay, so equation involving some difference product of two or more polynomials is called algebraic equation. Okay, suppose f of x is equal to x plus x square. Okay, so here it involves two polynomials, sum of two polynomials, so it is again an algebraic equation. Okay, so this is one equation in polynomial x, this is another equation in polynomial x, and since it involves sum of these, so it is an algebraic expression or algebraic equation. Next is transcendental equation. Okay, so next is transcendental equation. So the equation involving that is the equation which contains exponential, logarithmic or trigonometric. Okay, so the equation involving exponential terms, logarithm terms and trigonometric terms is called transcendental equation. So using the methods which we have already discussed in the first video, so those methods are used, that is bisection method, regular falsy method or false position method, secant method or Newton-Raphson method. So using these methods we are going to solve any equation which is of these forms also, which contains these terms also. Okay, so an equation which involves these terms or exponential, logarithmic or trigonometric terms is called as transcendental equation. So in order to find, when you are in a process of finding the solution by using these methods, there is always error. Okay, so there is always some error which creeps in the final result. Okay, so based on that they may ask you to find the result error also. Sometimes in some cases they may ask you to find absolute error, or they may ask you to find relative error, or they may ask you to find percentage error. These three errors you just have to remember. Okay, so the types of error here. So why these error occur? So because all these are approximate values, so all the solutions which we use or all the solutions which we are going to get by using either numerical integration or for the solution of algebraic or transcendental equation, or even in the third topic also, solution for differential equations, all these are approximate solutions, not the exact solutions. Okay, so they may ask you to find error also in some cases. Okay, so it is better to know about the types of error asked. There are three types only majorly, so they have to ask in these three types only. So first is absolute error. First is absolute error. So absolute error is equal to exact value minus approximate value. Exact value minus approximate value is called as absolute error. Next is relative error. Relative error is exact value modulus of exact value minus approximate value divided by exact value. Okay, so this is called as relative error. Next is percentage error. Percentage error. So mostly this is most widely used, or this is most widely probability of asking the question if they ask from these errors. Okay, so percentage error is relative error multiplied by 100%. Relative error is this formula. So this formula, if you multiply it with 100%, it will give you the percentage error. Okay, so just remember these three formulas. If they ask, you can easily solve. Okay, so next we'll discuss about iterative methods. Okay, so next we'll discuss about iterative methods, because the methods which are used to solve these algebraic or transcendental equations are called as iterative methods only. Okay, so iterate is a Latin word. It is a Latin word which means to repeat. Okay, so in iterative methods successive approximations are taken, so that is why it is called as to repeat. So successively we are taking the values, so it is called as repetitive methods or iterative methods. So iterative methods are classified into two types. Iterative methods are classified into two types. One is interpolation method. Interpolation method or bracketing method, or it is also called as bracketing method. And the second type of iterative methods is extrapolation method. Extrapolation method, or it is also called open end method. Open end method. So this classification of iterative methods, that is as interpolation method or extrapolation method, is done based on the initial estimates. So this classification is done based on initial estimates. Okay, so how we are taking the initial estimates, based on that you are going to have this interpolation method or extrapolation method. So interpolation method, so first we'll discuss about interpolation methods. So in this two estimates are made. So two estimates are made, that is we are going to assume two initial estimates. So in these two estimates, one is positive and other is negative. Okay, so one is positive, that is a positive value should be obtained with the function. So if you are given with y is equal to some f of x and you have taken the initial estimates as a and b, suppose a and b, then f of a and f of b should have opposite signs. Should have opposite signs. Not necessarily a and b should be opposite sign, but f of a and f of b should have opposite signs. Okay, so like that you have to take the initial estimates. Next is by proper selection of the method, that is interpolation method, that is by proper selection of algorithm. Okay, by proper selection of algorithm, based on the method, you have the separate algorithm or separate mechanism you are going to follow in order to find the successive approximation. So by using the algorithm, we are going to find successive approximations. Okay, so we are going to find the successive approximations by using the algorithm. Okay, so this iteration, so this continues. Okay, so this based on the algorithm, you are having the successive approximation, and then it continues. It is because it is iterative, so it is to repeat. So when should this algorithm or finding the successive approximations should stop is the gap between the values. Okay, so the gap between the estimates which are obtained by successive approximations. Okay, so the gap between them must be as low as possible, within the acceptable range. So within the acceptable range, if the gap between them is there, so then we can stop the iteration there. Okay, so I'll explain you, don't worry. So I'll explain you when I take the method and solve it by using an example. Okay, so the most popular interpolation methods, or the methods in solving transcendental or algebraic equations is, that is interpolation methods are bisection method. Examples of interpolation method are bisection method, and second is false position method. Okay, so false position method. So in extrapolation method also, first of all, what we are going to take is only one initial estimate we are going to take. Only one initial estimate we are going to take. Okay. Second, by using algorithm, that is by using the methodology of the corresponding method, we are going to find the successive approximations. Then the question is when this iteration should stop. So in this extrapolation method, the iteration stops when the difference between two successive iterations is small. Okay, so if the difference between two successive iterations are small, then you can stop the algorithm or stop iterations. Okay, and that will be your final answer. So if the difference between them is very small, then you can stop the iterations, and that will be your final answer. Okay, so if the difference is large, you have to find the corresponding successive approximations also. So you have to continue this method until the difference between two successive approximations is almost equal. Okay, that means the difference between them must be almost equal to 0. Okay, so then you can stop the iteration, and that will be your final value. Okay, so the example of extrapolation method is Newton-Raphson method. Newton-Raphson method. Okay, so these are the two types of iterative methods which you have, and bisection method, false position method, and extrapolation method example is Newton-Raphson method. Okay.